Hey everybody, it's Brian here from quantlabs.net. I've got a pretty exciting video for you. It's about 25 minutes. So it's broken up into 3 segments. The first segment will walk you through how to convert from, let's say, a research paper or trading idea symbolically. I've done some research on Mupad. I love it very much. And then be able to take that Mupad set of expressions and be able to convert them into C or C++. And I show you, and I walk you through that process, and I've included all the files and everything for it. Now, I will give you a quick snapshot on that, but at the end, towards the end of the video, I've got 2 other segments at approximately 15 minutes. I show you how to convert from Mupad to a Simulink function block, which can be added to your Simulink trading models, and then at 21 minutes approximately, we show you how to convert from a Mupad set of expressions to Matlab M custom functions, which can be also implemented in your trading model. Now, let me give you a little backstory here. So we got this link here, which I do demonstrate in the video. This is here. And what it basically does, it just takes a set of models or algorithms as expressed here, and then it enables you to convert them to a Matlab M function, and then from there be able to convert them into a C or C++ library with code. And you can obviously generate DLLs or static libraries from them for your operating system, no matter if you're Windows, Mac or Linux. Doesn't really matter, as long as you have that right version for Mac or for Matlab. So let me just take you, and I have, and if you come to the link on the blog at quantlabs.net, this is what we got. So here's the history of that link I just showed you. Here's the Mupad expression file, the Mupad Notebook file. I'll go through this in detail in the first segment. And then I have the complete command history on how to generate, how you convert from the MN file, the Mupad Notebook file, and you're able to evaluate it and then enable Matlab, the workspace, to convert some of the key variables from the Mupad Notebook, and then be able to generate your formula from within Mupad, and then be able to take something like this expression, this algorithm or calculation or whatever, and then create a custom M function from that. And then of course I do other demonstrations demonstrating how to code generate from that Matlab M function, and it's going to generate with a MEX file, which you don't really want. Using the C code is another option. It just generates these weird functions. Is really not a worthy option. And then of course I show you the Matlab Coder and how to generate C code from that. And then again, as I said, we have these other additions as well to convert from the Mupad Notebook and create a Simulink model function or function block, as well as a custom M function as well. And you can deploy it into your Simulink. It's very powerful, very, very powerful. And again, because you get the Matlab M function, you can, of course, convert that M function into .NET assemblies for DLLs for your C# programs. Of course, that is including my custom trading platform that I include for all my members on the Elite side, as well as, if you want, you can do Java jar files and Excel add-ins. It's very cool. It's just very cool. You cannot do half of it. You can't even do a lot of this with any open source languages like R or Python. They just don't have they're just left behind with this capability. And this is that new workflow I've talked about, but I haven't included Simulink at this point to demonstrate that power with the state flow, as well as the capability to generate HDL code from it for, again, if you really got to go high, ultra lowest frequency, this is the path to use Simulink for FPGA, for HDL, hardware description language, using Verilog for Xilinx, or the Altera for VHDL languages. Very cool, and this is it. This is the Holy Bible to it all. Hopefully you enjoy it, and upcoming are those 3 segments I talked about. Talk to you later. Hey, Brian here. I am going to show you some very, very cool things. First off, I want people to, basically what I'm going to be showing you is an example using Mupad. Basically using Mupad, for this case, an options model. Very basic stuff. This, what I'm showing you, I'll provide the link to this, but I couldn't get it working, so I made a derivative of it to get it working. So I'm going to walk you through that to show you how I got it working, what I've got, and some of the extensions that you can use to generate C code or C++ code, and that is using both the symbolic math toolbox, as well as the Matlab Coder itself. So let's dive in. First of all, let me show you the Mupad notebooks file itself. Okay, so this is Matlab 2014A. I have a Mupad notebook. So when you type in Mupad, you can come into this interface. It's very cool. Basically, what happens is I'm using, like I said, a derivative of this stuff here. Now, just to save you a lot of time, I didn't include any of these weird symbols or the subscript stuff because it just didn't convert properly, and I'll show you that in a minute. But I did use some of the basic stuff of the forward rate, the sigma hat, the D1, and all that. So let me show you that. So, in a nutshell, what I did was I was able to copy each of these calculations, calculating N, forward rate, sigma hat, D1, D2, and call, and of course the put. And because the Mupad, these are the responses that you would get from the algorithm that's generated from this, and then you can save it. Now, just so people know, I'm going to include this. You can save this as a MN file. I think it's called Mupad Notebook file, or Notepad Notebook file. And then you can also generate a PDF for it as well. Just save as, and then, export. So yeah, I'll include that as well. So you can create a PDF if you want. You can create an HTML or whatever, but you get the idea. So from there, because I have this MN file, this Matlab MN file, what I had to do was, basically, I didn't care about these symbols. Let me show you another way I got around it. I created a model, or just call it model, using the file name. In this case, as I said, the proper one that works is a relative option model .mn. So I use that. Actually, because I'm such a nice guy, I have included all the necessary things to get you working. So in this case, here's the Mupad notebooks file, the relative option model MM. This is what it would contain. You save that, as I said, and then I've included the command history of the Matlab. So really what I'm doing here is I'm just using these 3 right here, but in this case I'm just relative options models, what I'm calling here. Everything else stays the same in these 3 lines. Call up the model, the Mupad model, that session. Here's the handle, assign that handle to NB, and then you can evaluate the Mupad notebook in the command prompt. So essentially what that does, it will allow you to have access to the Mupad resources from within the Matlab workspace. So essentially, here's the workspace, all the available variables, symbols, and all that. And then I can, from there, generate code and MATLAB functions. So let me just show you what I mean. Okay, so we create the MN file. We create that model variable, as I told you. We call the Mupad editor or notebook under this name here. Assigns a handle, and then we evaluate that Mupad notebook of NB. Okay, so what needs to happen from there is, because now we have Mupad session in memory as well as the workspace of MATLAB, we need to convert the necessary. Now you won't find this in what I'm about to show you. You will not find these lines, this get var function in this HTML file. Okay, so this is not included. These set of commands are not included in this link here. So let me just show you what I am referring to. Okay, so what we're doing is we're grabbing from the Mupad handle the S1 variable from within Mupad. So essentially what I'm doing here is there is S1, S2. I'm going to grab also copy put, and this is all within the Mupad call, D1, sigma hat, F. All of those gets copied into the workspace for MATLAB. So there's one for S1 from Mupad, and then it creates that S1 symbol or within the workspace of MATLAB. So I do the same thing with a put, and then I do a bunch of other stuff as well. Call, and yeah, that's it. So essentially, when I'm just focusing again, I just show you the S1 how to do it, and then we are going to copy the Mupad put variable, create a symbol for it within the MATLAB workspace. Boom. Well, and basically it's going to just basically copy the entire formula from within Mupad, and then do the same thing with the call as well to create that call symbol. We create this. So what we can do now, this is where it gets very cool, is we can convert this guy, the call symbol, and create a MATLAB function for it. So we call, and then we create a new file, MATLAB M function called call underscore ROP, and do the same thing with the put underscore ROP. Okay, and so now we get two new custom M functions for the call and the put from within Mupad. Okay, let me just show you those. That's very cool. Okay, so we are now just created this call ROP. So this is from within that Mupad, and we've converted it basically. And the other one is the put. Okay, so we have those two now M functions. So we can take these M functions, do a lot of things with them. For instance, we can deploy them and implement them into a Simulink model, or we can generate C code from them, which I'm about to show you. There's different ways to do it. So in this same call history, what I've done was I'm going to generate some code in C. So if you want to go back to the that URL I gave you originally, there's a lot of stuff I didn't bother doing. All this stuff I didn't bother. Some of it worked, some of it didn't work. But this will walk you through the process to create your MATLAB function, which I just showed you. But here you can create a co-generate your call ROP or put ROP functions into C. But there's always that little gotcha, and it's a big gotcha, because what it's really doing is just generating an MEX file, which really is not 100% C. It's just it has all these dependencies from within MATLAB, and it's not something I would use. So for instance, here's the MX, MEX, the MEX stuff, and it's a complete mess. So I didn't bother with that at all. And here's the MEX, this is what's included, and yeah, you see all this MEX stuff, and the C will call them MEX, and it's just, yeah, I wouldn't go down that. That's a legacy option. So you could use something else called C code, which is part of the symbolic math toolbox, and that will call C. But then you get all these warnings because it's using this ERF and doesn't know what to do with it. So again, kind of useless, but I did include it here. Left it, you do what you like with it. But I did go one step farther. So that's as far as I could go with some of the examples. But what I did do is I did use the Matlab Coder. So essentially what I've done here is just so people understand how to use it. It's kind of a little more intelligent in the 2014A. So I just added the call _ROPM and put _ROPN, and then I just converted it, the input variables, and just converted them to 1-by-1 doubles. And that's an easy process within this little GUI here. And then of course the powerful thing is we can build. Now let me just show you what we have here. We can create C++ static library, a dynamic library, an executable, and we can use that messy MEX, but not MEX. And then you just go build. Okay, and then of course we have more settings that we have full control over. We can minimize, you know, it's pretty powerful, I think. You know, yeah. So I'm going to let you play with this as part of this process. And then of course, as part of that dependency, you have to define your compiler within the Matlab Coder. So in my case, I'm using the Visual C++ 2012 compiler. Now, the cool thing about this is this will work on any platform. So if you're Linux, you can use the GCC. If you're Mac OS X, you can use the GCC as well to convert this. Very powerful, very powerful. So obviously you generate by building, or you can just generate the code alone. But what happens is when you generate the code, it'll finish, and then you get this cool little report. So here's the code. Now I do believe you can minimize this even further, as there was an option there to generate in one file. And then you get your header files, your C files, your some other external dependencies that Matlab will generate for you on your behalf with this infinity non-number, and so on and so forth. It looks fairly efficient. As part of the package, you'll also include the Matlab functions that I converted from, and again, you have all the full control to convert the Matlab function into C. And again, you can do that with C++, I believe. And yeah, let's just take a look at the package here. Yeah, so here's the code-generated stuff, and there you go. You got your, as I said, you got your object files for your build within the Visual Studio, the header files, C files, so on and so forth. And then I think there was some example code to show you how you can call it as well. Let me just see, where am I? Where am I? Yeah, here. Okay, so let's go back to the report. So C code. Yeah, here's your call ROP, I believe. Oh no, that's not the same one I'm thinking. Never mind. So, and in essence, I'm hoping you can see the power of this. So you can now, as I demonstrated here, you can convert from Mupad all this stuff with your formula, calculation, your algorithm gives you to confirm that this is exactly what you want, and then be able to generate your MATLAB function as I showed here. And not only that, but take that MATLAB function and then be able to generate your C++ or C code from that. Very powerful. Now, we can take it even further, and we can now deploy these MATLAB M functions and put them into Simulink models for system level. So we can have a whole whack load of these. Okay, so from my perspective, this is an updated game changer. I hope you can see the power of it. Again, this is not limited to just Windows. It can be done on any operating system. And again, it just doesn't stop there. You could, because you have this MATLAB M function, you could, let's say, develop .NET assemblies for that. You could develop Java jar files, Excel add-ins. I mean, on and on it goes, right? I mean, think about it. Let's just let me show you what we got here. No, don't have it. But yeah, you can definitely take these M functions and develop and extend them again to, like I said, Excel, Java, and .NET. Hopefully this excites you. I hope it does, because I'm definitely excited, as you can tell by my voice. Have a good day. So what I'm going to do in this video segment is I'm going to show you the basics of creating a MATLAB function block, which is really a function block for Simulink. And that's going to be the equivalent of a custom MATLAB M function. And that's going to be created from a Mupad expression. So I'm going to just show you the basics of these instructions here, and then show you an algorithm and show you how to do the same thing. So essentially here I'm using MATLAB 2014A. This is the first instruction. So you want to create a Mupad handle. That will open up a, a Mupad session and create a handle for it. And that's what this does. Okay, and then the second line is you go into your Mupad notebook, and then you just enter this in as instructed here. So you just create that little Mupad symbolic expression, which would be equivalent of whatever algorithms I use, and then from there, I guess you save it or whatever. And then what will happen is you want to create the variable within R, the R variable within the Mupad session, which is the return here, and then convert that into a variable of a MATLAB workspace variable. So this will be the symbol from the Mupad session. So that's within the MATLAB workspace. And this is what it'll obviously return, is the equivalent of that expression that you created in Mupad. Voila, right? So from there, what we can do is, if you look at R, that's what R will equal, is this expression within the MATLAB workspace. So now what we do, let me just show you some steps. So we create the R workspace variable from the R Mupad expression that we just created. So this is the result, as I just showed you. So now what we're going to do is we're going to open up the Simulink model as instructed here, and got that here and here. And what will happen is when you open this, this will create a new Simulink blank space, canvas, I guess, and then before that'll be empty. And then what you do is from there you create a function block from your workspace variable R, and it will create it and put it into and call it my block. Okay, so that becomes now available to Simulink. That's pretty cool. So obviously we do that, and we run this to open this, the system for which is the Simulink model, and then what we do is we create that block, as we can see here. So it's called my block. So this is what it will look like, the MATLAB function. That's it. Good to go. Oh, and the other thing is you want to see that this also includes the directive for code generation. So then we can take this and do fancy. Let's see if this works. Code, and then create our model or whatnot from it. But we also need the equivalent of the inflow and outflow as well for the Simulink model. But that's where we go, and as you can see from there, we can also do not just C or C++. Let me just get out of this. Not only that, but we can also create our HDL code as well. Pretty killer, if you ask me, and that's for FPGA. Okay, and that's just the very basics of how to convert from a Mupad expression to the equivalent of our block, which is our Simulink, and then we can create code for it, not only in the M script here, but we also have the ability from the Simulink model, once we add our inflow outflow, and then we can generate our C++ from it, or C code, just so people understand the crash course of what we're doing. So in this video segment, I'm going to show you how to create a MATLAB function from Mupad expressions. I think this might be a little more useful to deploy into my Simulink model. There is another example of that will create a Simulink block, but this might be a little more flexible going through this path that I'm about to show you. So what we do here is we do our usual create a handle for our Mupad session. So that's what we do here. And when we have that Mupad session open, as in here, what we're going to do is we're going to add these expressions to the Mupad editor. So in essence, that's what we do here. Do a save, obviously. And now what we're going to do is we're going to convert the Mupad variable here, S, this one, into a MATLAB workspace variable called S. That's what we do here, and this is what it results in, is the actual function of all these different expressions that we have within our Mupad editor. Okay, so from there we now got to create a handle for the MATLAB functions. We use this command here, a MATLAB function, right here, and results in this with ABR as a result. Yeah, here. So we get our ABR as the input, and then from there we create our MATLAB function from S, which is really the handle, and then create our MATLAB function called Cartesian, and that's what we create, which is created via here. So this is what it finally looks like. But notice we don't have the code gen directive as in before with the Simulink block. And then here's all the lines that we use for the Mupad session. Personally, I think that's very cool. And you can see I will be creating MATLAB functions like this for my Simulink model. So I just want to show you how to do that and go from there. Talk to you later.